Is functional programming declarative? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So, when people describe functional programming, one thing that comes up a lot is saying that functional programming is a declarative paradigm. And then to further explain what declarative means, they'll say it means you say what you intend to do and what you want without telling how you do it. So you say, I want the map I want this list transformed, but you don't say how to do it, which is like giving a for loop with an increment variable that you go through the loop, stop at the end of the list, etc. Now, I want to challenge this whole idea because I don't think it holds water. It might be a good kind of intuitive idea that FP is somehow better at expressing some kind of problems because it's declarative, but I just don't like the idea in general. And the idea really, the reason I don't like it is every paradigm claims to be declarative, and it can if you take declarative as a relative term. So when I do a for loop in even something like C, that's declarative compared to assembly, because in assembly I have to use a goto, right? I have to say, how do I loop? What line of code do I jump to? What it has a label, and I'm going to jump to it after I do this comparison, right? And if you go down to something like machine code, you might even be choosing what register you're storing your increment variable in. And looping becomes like a design pattern for how, for a certain pattern of using gotos and increment variables and stuff like that. So the idea that you're telling it how to do it, that you're telling it what you want and not how to do it, every paradigm or every language that is better than the last, more expressive than the last, can claim that. And so I just think that it's kind of like a meaningless word. Now you can say that it's a relative term, right? That for certain constructs like, let's say a map or a filter or a reduce, you can say that that is more declarative than a for loop. But it's only relative. And so to use the term declarative in an absolute sense is meaningless. To say functional programming is a declarative paradigm, okay, it's just not, it doesn't mean anything. Because in 20 years, 30 years, there might be an improvement, a better paradigm, and someone is going to claim that that one is declarative, and they're going to compare it to functional programming, and they're going to say, see, it's way more declarative than that one. Okay, so it's just not, I just think we should stop using this term, at least in an absolute way. Maybe you can use it in a relative way. But the only thing it means in a relative way is the details that I have to worry about are taken care of for me, right? So what's the name of the index variable as I loop through this? That's gone. That's something you have to care about in the for loop, but you don't have to care about that when you're doing map. Just like in a for loop, you don't have to care about what register you're storing your stuff in. That's taken care of for you by the for loop and the compiler. Okay. So another thing people will say is that you don't have to worry about how the map works. That you could say, oh, that map could be totally replaced by the compiler with a like parallel implementation or some other implementation. Now this is sometimes true, that the compiler will somehow, for a certain construct, it will somehow insert itself and maintain the semantics that it promises while somehow optimizing it. And we see this in SQL a lot. You send a SQL statement, we know that the SQL will be optimized by the database, and the order that we put the joins in isn't really the isn't really the order that stuff will be executed in. There's going to be an optimization step. But this, again, is simply not unique to what we would call declarative languages. The C++ compiler, the GNU C compiler, they all have optimization steps. The JIT, the Java just-in-time compiler, is going to insert itself into the process, rearrange your operations, and just do what it wants with it. And it's supposed to maintain a certain semantic, but sometimes that's not intuitive of what it's going to be doing. So I think also that this idea that declarative gives the compiler leeway to optimize, it's only a relative term. Maybe Haskell is more optimizable than C because it is more declarative. It's at a higher level, but it's not. It's a relative thing again. It's not about Haskell is declarative and C is not. So I really think that we need to stop using this. If anything is only like a way to provoke people to push further, even map. If you have a given language, the idea of map is concrete. It is not declarative. You can look up the definition of map in your language. So in Clojure, you can just look it up in the code. In Haskell, you can just look it up in the code, and it's fixed. You know how it works. It executes certain known deterministic steps to achieve its aim, to achieve what the semantics of that operation are. And to claim that it's declarative some way is, as opposed to, say, a for loop, which you can say, well, it's going to compile to this goto and this, all of that is the same. It's exactly the same. If it means anything, it simply means that map is a term, or has a meaning that is robust enough that you can consider it conceptually opaque, meaning you don't have to think about how it's implemented. It's clear enough and it works without corner cases enough that you just don't have to worry about it anymore. Right? There's a lot more to worry about with a for loop. Like, did I initialize my variable? Did I increment it? Am I missing an off by one error in my termination condition? right? There's all these things you have to worry about, and so you're not dealing with the problem as directly. But map lets you forget about all those problems, and it has no corner cases. It deals with the empty list just fine. It deals with an infinite list just fine. It's simply easier to wrap your head around. And so I think that might be what people are trying to get at when they talk about it being declarative, is that it's conceptually opaque. Like, you can forget how it actually works if you choose to. And you can do what you're supposed to be able to do with good object-oriented programming, which is consider only the interface and forget about the implementation, right? And so in that same way, good object-oriented programming is declarative, right? And you see, this term just is not that meaningful. I think we should stop using it. Map is actually more concrete than a for loop. You can do a lot of stuff with a for loop. It is an abstract idea, right? It's about, and there's an initialization step, there is a termination condition, and there is a thing that happens on every iteration. And then there's a body. That's a very general construct. You can do a lot with that. A map, on the other hand, is only about transforming one list into another. It can't change the number of items in the list, and it can only apply the same operation to every item in the list. It can't do like a for loop. You could step by 3, right? And you could skip things. Or you could terminate early and not hit the end of the list, right? There's all sorts of stuff you could do. You can't do that with map. However, a map is more concrete. However, it's more abstract than the particular for loops that do implement that same pattern. That pattern of transform everything in one list into another list, right? So it is more abstract because it's eliminating a lot of the details. You don't have to name the index variable. You don't have to worry about the termination condition. You don't have to worry about the incrementing the variable on each step. Right? So it is more abstract than those particular patterns of usage. See, I'm not saying declarative, it's just more abstract. You're not worried about those details. You've elided details. That's what makes it abstract. But the real, abstract, concrete, that's not what's important. What's important is that it gets you closer to the problem domain. It lets you, by eliding those details, it lets you focus more on solving the problem. It is one step closer to speaking about the particular domain. Just one step. It's just one step closer to speaking about the domain you're interested in, as opposed to, speaking about incrementing integers and indexing that into an array, right? Well, okay, so that's my rant on declarative programming. I'm sure this is just my opinion. I'm sure that there are people who will defend the idea of it being declarative, but there's also people out there who have real definitions of declarative, and I've seen them, I don't quite understand them, but it has to do with whether the operations that a language performs are deterministic at all. And in most functional languages, they are deterministic. If you knew all of the rules that the compiler was following, you could just figure out what operations were going to happen in what order. Even with like lazy evaluation and everything, they're all very deterministic. All right. I'd love to continue this discussion on Twitter. I'm at Eric Normand. You can also email me at eric@lispcast.com. And let's get into this. Let's get into this discussion, because I really think we should stop using the term declarative to describe functional programming. It doesn't hold water. All right. Thanks so much. See you later.